In this session, let's start dealing with the interest rate specific derivative instruments, where our focus is primarily on interest rate caps and interest rate floors. And combining these two, we will even create what we call as collars. So these are the three instruments which are of more important for us. Of course, once we understand the cap and the floor, we can very well talk about the collar on the same lines. Now, whenever we talk about interest rate cap, as the word itself is saying, I am putting a cap on the interest rate. So it's as good as saying, let's say I am borrowing. Let's say I am borrowing at a floating rate. Now, once I have borrowed at a floating rate, at regular intervals, probably on a monthly basis or quarterly basis, whatever is my payment period, at regular intervals, depending on what is the floating rate that is persisting at that point, my payment would be depending on that. Rather than that, if I take a cap, it's as good as saying, okay, as long, let's say I have set the cap at around 8%. It's as good as saying, if the interest rate, if the floating rate is less than 8%, I'll still pay the floating rate itself. But if the floating rate crosses 8%, I'll only pay 8%. That is how we are, in a crudest sense, I can talk about an interest rate cap in that typical manner, which means probably it is looking more like a call option itself. If you remember the way we talk about a typical call option, if the stock price is less than, let's say, a strike price of 100, I will purchase it at the stock price itself. But if the stock price goes greater than 100, I will purchase the stock at 100 only. That is what is the typical definition of a call option. The similar logic is applying on the interest rates, which is what we call as the interest rate cap. In other ways, whatever, in case the stock price is greater than 100, then we talk about stock price minus 100 is the payoff, whereas the stock price is less than 100, 0 is the payoff. Same logic again, if the market rate is greater than the strike rate, which is 8%, then the difference between the two is the payoff, otherwise 0 is the payoff. So probably what you can see is there are a lot of similarities that are existing between the interest rate cap and probably call option on a stock, right? Same logic goes with interest rate floor. It is similar to that of a put option on a stock, which means when the market rate is lesser than the strike rate, there is a benefit which is to the extent of strike rate minus the market rate, whereas when the market rate goes above the strike rate, the payoff is going to be 0, which is similar again to the concept of the put option. But the only thing is, here we talk about a series of payments against one single fixed rate. That is the major difference that we get. Otherwise, even this is same as call option on some reference rate, right? If the actual market rate is greater than the reference rate, the difference between the two rates multiplied by the notional principal amount is what is the benefit that buyer, call option buyer, is typically getting. But in this case, the prime difference that comes out with respect to a cap is, in case of a cap, we don't talk about one payment, we talk about series of payments. So the typical problem would be modeled like this. We talk about a 2-year cap, probably with annual or semi-annual payments for a strike rate of, let's say, 8%. So what does that mean then? Every year when you are making the payment, right, every year when you are making the payment, you will check out whether that rate is above 8% or below 8%. If it is above 8%, you will fix it at 8%. If it is below 8%, you will go with the market rate itself. So in that case, what is happening is, for each payment there may be a different set of benefit. So the sum of all those benefits is what will add up to the total value of the cap or to the total value of the floor. So it's not one payment which we are talking of when we talk about a cap or a floor. It's a series of payments, and each such payment value is what we are calling as a caplet or a floorlet. So that is where we need to be comfortable in terms of valuation, especially for caps and floors, rather than a simple call option on interest rate. There is a difference between these two. Call option on interest rate versus cap. The only thing is, cap contains multiple call options on the interest rates for multiple time periods. So each call option on interest rate for a different time period, we call it as a caplet, and series of caplets is what we call as a cap. So that is one valuation difference you have to be comfortable with when we talk about caps and floors. It's not one calculation we have to do, we need to do a series of calculations for each of the periods and then sum up all of them to arrive at the overall value of the cap or overall value of the floor. We'll take one numerical example to demonstrate that particular aspect. But before we get into it, we would also look at a slight improvised version of taking the cap and the floor together, or dealing with or trading with the cap and the floor together, which will result in the construction of a collar. So the simple way to define a collar is combine the floor as well as a cap, wherein you buy one of them, you sell the other. So either you do a buying a cap or selling a floor, or buying a floor and selling the cap, with the only requirement being both of them need to be at the same strike rate, same maturity period and the same settlement date. All of them should be the same. Either you do a buy cap and sell floor, or sell cap and buy floor, and both of them at the same strike rate. Then you are actually creating the position of a collar. That kind of a position is what we call as a collar. And especially if the premium received is same as the premium paid, premium received on selling versus premium paid on buying, if both of them are one and the same, that will result in case of a zero cost collar, because net payment that you are doing as on day 0 is 0 itself. Whatever you are receiving on a sell position is what you are paying on a buy position, resulting in an overall position of 0. That's where we call those kind of collars as zero cost collar. Now let's demonstrate one numerical example for valuing the interest rate cap. For that, you assume the interest rates are follows. So the 1 year interest rate currently, I will take it as 5%. Okay, let me create an interest rate tree. The current 1 year rate is 5%. After 1 year, it may become either 8% or 6.5%. and if it had become 8, we are saying it can go to either 10.5 or 8.5 the next year, and if it is gone to 6.5, it will be either 8.5 or 7 the next year. So this is what is the typical lookup of the interest rate tree. Based on that, probably I would like to look at both a 2-year cap valuation as well as a 2-year floor valuation for a notional principal of 10 million, and probably let me take a strike rate of 7%. Let me assume that the strike rate is 7% because there is no strike rate mentioned in this numerical. So let me go ahead assuming that the strike rate is 7%. Now how do you go about with it? So because this is a 2-year cap, I'll do it for cap first. Because it's a 2-year cap and the payments are annual, so I have 2 caplets. What are those? There is a 1-year caplet and there is a 2-year caplet. So the summation of the value of these 2 caplets is what will create the value for a 2-year cap. So how do I do that? First let me go ahead with a 1-year caplet. How do I do the value for a 1-year caplet? So look at, the simple way I suggest is, look at the strike rate 7%. So if the market rate goes to 8%, there is a benefit of 1%. So the payoff here, which means the actual benefit, whatever is the interest rate at the beginning of the period, the benefit will come at the end of the period. So whenever I am talking about the benefit or the payoff with respect to caps, all I would take is whatever is the difference, this minus 7%, whatever is the difference, multiplied by the notional principal 10 million. So let me take it as 10 itself, so we'll have the answer in millions only. So this minus 7% into 10 million, and because this is per year, I don't need to adjust it for the number of years. So if it has been a 6 monthly, then probably taking it as 0.5. Okay, so that is the total benefit, but that benefit comes at the end of the year. So I have to discount it to get it a value at the beginning of the year. I have to discount it by this particular rate. I am discounting it by this particular rate, telling me that the value at this particular node, the value of the caplet, in case the interest rate goes to 8%, it is going to be 0.09 million. If the interest rate goes to 6.5%, it will be 0 because the strike rate is 7%. So I will expire that option. So the value is going to be 0, or so the payoff is going to be 0 here. Now from these two I can find out what is my expected payoff, wherein I am taking 50% chance of going up and 50% chance of going down, working out to the expected payoff being this number. And if I want to find out the value 1 period before, this is again working out as divided by 1 plus the interest rate as of today, which is working out to 0.04, which is working out to 0.04 million, or 0.04 million, and I can easily work it out as, probably multiply it, right? It is working out to, I can keep it in millions itself, because this one also I have kept it as 10 million. So the value is 0.04 million, working out to, if I multiply this entire thing by 1 million, it's working out to somewhere around 44,000. This number is working out to somewhere around 44,000, as the value of a 1 year caplet. The 1 year caplet is going with the value of around 44,000. The same logic I can go with a 2-year caplet now, right? Probably let me look at a 2-year caplet, right? Otherwise let me keep this as consistency in terms of 0.044 million. For a 2-year caplet also, what I can look at is, I will look at the expiry as the second year. So in this position, if the market rate goes to 10.5 million, what is the benefit? The payoff is going to be 10.5 minus 7% multiplied by what is the notional principal, 10 million per year, discounted by this particular interest rate, which is 10%, 10.5%. Because in case of caps, the interest rate differential, whatever is coming up, the benefit will come at the end of the period. So if I want to find out the value of the benefit at the beginning of the period, I have to discount it with that corresponding interest rate. So this is the benefit. And in case the interest rate goes to 8.5%, still there is a benefit with my strike rate of 7%, multiplied by the same 10 million multiplied by 1 divided by 1 plus 8.5%. So this one is giving me 0.13 as the benefit. And of course, if the market rate goes to 7%, it hardly matters whether I am exercising the option or not exercising the option. So I will be getting a 0 only as the payoff there. So at each of the notes, I can work out for what is the expected payoff by multiplying 0.5 times this particular payoff versus 0.5 times 0.13. So the expected payoff at that node is 0.22. The same logic here, I can find out the expected payoff 0.5 times 0.13 plus 0.5 times 0, giving me that the expected payoff is going to be this at the end of 2 years. I can discount this at the end of 1 year to 1 year period by discounting it by the interest rate of 1 year. So bringing 0.22 to 0.21. Similarly, the same logic, 0.06, I will discount it by 6.5%, working out to 0.064. Again, there is a 50% chance of this value and another 50% chance of this value. So the expected payoff here is 0.5 times 0.21 plus 0.5 times 0.06, resulting in an expected value of this much, and discount this number by 1 plus 5%, working out to 0.13. So the 2-year caplet is having a worth of 0.13. The 1-year caplet is having a worth of 0.04 million. So when I talk about a 2-year cap, the worth is this plus this. That is the worth of 2-year cap. So probably if I take it into million, because this number is in million, so if I multiply it by a million, it says that the worth of this 2-year cap is going to be 175,305. The same logic if I have to use for a floorlet. Now let me do it very quickly. The floorlet, where we are talking of 7% as the strike rate, right? When I am talking of 7% as the strike rate, so this will go expired. Whereas in this case, I will get a benefit of 7% minus 6.5% multiplied by 10, everything else remaining the same. and multiplied by 1 and then dividing the same by 1 plus 6.5%. So the payoff is going to be something like this, and probably a 0 in the when the interest rate goes to 8%. So the expected payoff again is 0.5 times this value plus 0.5 times this value, resulting in this being the expected payoff. Discount it to the present value, saying this plus 5%, overall resulting in the 1 year floorlet having a value of 0.02 million. And going with the same logic, a 2-year caplet or floorlet literally has 0 value, because none of them will be exercised in case of a 2-year floorlet. So 2-year floorlet in this example has a 0 value. So when I am talking about a 2-year floor, it is 1 year floorlet plus 2-year floorlet, giving me a total value of 0.02 million, working out to 20 odd thousand. So if I multiply the same by 1 million, so this is giving me 22,356. So a 2-year cap is costing me 175,000, whereas a 2-year floor is costing 22,356. This is how we do the pricing for a cap floor by taking considerations of caplets and the floorlets. So this is what is the basic understanding of this particular chapter. If you have any further queries regarding the same, you can very well get back to me by giving me a call on the number that I have given below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.